Let's use RSpec to create some characterization tests for the convert function before we start refactoring it. Remember, we would be doing all of this in a scratch branch of the code so that any changes or exploration that we do don't accidentally get back into the main code base. We're going to use Michael Feathers' suggestion for creating characterization tests, which is we're going to write some tests that will probably fail because our understanding of the code being tested is incomplete, but we can use the information from the failure error messages to change the tests so that they match the behavior that the code has right now. So let's take a look at our spec file. What I'm going to do is start building up a list in which each key is a method call to an argument that we might call convert with, and the corresponding value is the result that we think convert will return. Now, we mentioned in the text that the nominal purpose of this convert function is to tell us what year it is, given that the number of days that have passed and the fact that the starting year was 1980. Based on our intuition, one question we might ask is, if 365 days have passed, does that mean that it's the last day of 1980 or the first day of 1981? We could take a guess and say that it's the first day of 1981, and then try running a spec and see what answer we get. Well, it didn't work out. We thought 365 days would put us in 1981, but in fact, the value that the function actually computed is 1980. So, since we're creating a characterization test, our conclusion is our understanding of the code was wrong, and the right thing to do would be to say that 365 days puts us in 1980. That's clearly the intent of the code. And once we verified that that lets the test pass green, now we could ask ourselves, what other values might we want to test with? Well, certainly when you have a conditional expression, it's worth testing values that are right on the boundary. So for 365, we already tested this first while statement. What about 366? If our intuition is correct, 366 days should put us into 1981, right? So let's give it a try. We'll run the test. And we get a little bit of a surprise because the test case for 1980 for 365 days ran, but it looks like we're in an infinite loop. We appear to be stuck. And as a matter of fact, we are stuck because we have just run into the actual bug that the Microsoft Zune ran into on the last day of 2008. If we spent a little time debugging and tracing through the code, what we would ultimately discover is that there's a bug in TimeSetter that causes this to become an infinite loop when we happen to start from a leap year. In fact, the fix to the code would allow our test to complete. So this is a fortuitous example of how doing some exploratory testing and forcing yourself to write some tests can sometimes lead to the discovery of a bug. At this point, because we've got at least 2 tests passing green, we could ask ourselves, how much of the code have we actually covered? Keep in mind, we've been running simplecov this entire time, so every time we run the tests, it generates coverage information, which we can take a look at in a web browser. And we can see that we've covered 81% of the TimeSetter file. The only lines we're missing are the 2 lines in here that happen when this if clause becomes false. So far, none of our tests have exercised that. Now, if this code was properly factored, what we would like to do is have this turned into some kind of a method call that we could then stub out in our tests. We can't do that in this case, but it's a nice demonstration of why we would like to have seams in our code, and that's one of the things we're going to put in to improve the code when we refactor it. For now, suffice it to say that if you think about this for a while, you'll see that we need to come up with a test case in which we go through this loop twice, once when this if clause is true, so that we get these lines, and a second time when it's false, so that we get these. I'm going to do that by putting in an additional value here that will cause the loop to be struck twice, and we should now be able to run, we'll run our test one more time. We've got all green, and if we reload the coverage file, we can see that our coverage is now at 100% for C0. So, we found a place where we'd really like to have a seam, we found and we fixed a bug in the code, and we used characterization tests to improve our understanding of how the code is supposed to work.